We have to draw a combination graph which graphs these water charges here. Alright, there's a part A here first. We better do that first. It says, use the table to find the charge for using 520 kilolitres of water. Well, that would fit somewhere into this second bracket on the table. And it says the charge is $200 plus $1.50 for every kilolitre that's in excess of 300 kilolitres. Well, we're using 520 kilolitres, so that's in excess of 300. In fact, it's another 220 kilolitres more than 300, isn't it? So the amount of charge is going to be $200 plus $1.50 times the number of kilolitres which are more than 300. We're using 520, so that's 220 extra kilolitres. And that's how you work it out. Let's do it on the calculator. I'll do that multiplication bit first. 1.5 times 220 with the extra kilolitres plus our base charge of 200. $530. That's done that. Now we have to draw them on a graph. Now, and draw this table as a graph. It says to go up to 1,000 kilolitres, so we're going to put water usage on the bottom here. And that's measured in kilolitres, and we're going to put the charge up the side. So, water litre usage has to go up to 1,000. So that's pretty easy. Let's start naught. That's 1, 2, 3, 4. We'll make that 500 kilolitres. 7, 8, 9, 1,000 kilolitres. Now, to work out how far to go up the side here, I really need to know where my graph's going to end. We can get the end points for each section here, but that last end point I'm going to have to figure out for myself. Let's say someone uses 1,000 kilolitres of water. For 1,000 kilolitres, the charge is equal to, well, you'd definitely be in this bracket, and the charge is $650 plus $3 for every kilolitre that's more than 600. Well, if you're using 1,000, that's 400 extra kilolitres, and the charge is $3 times those 400. Okay, we can work that out on the calculator. So it's going to be 3 times 400. I'll do that bit first. Plus the 650. In other words, it's going to cost us $18.50. That gives us an idea how far our graph's going to go up, because we know the point 1,000 kilolitres, $1,850 is on the graph. What's that dollar sign doing there? That doesn't have to be there. Okay. It gives us an idea. We've got to get up there, so let's go up in. We'll go up each square equals 200, so that's $1,000 charge. That's $2,000 charge. Now we better start getting some graph happening here. this first section of the graph, if you use between 0 and $300 kilolitres of water, you are charged $200. In other words, it doesn't matter how much you use, as long as it's between 0 and 300, the charge is just $200. So all we're going to have is a straight line going along here. Between 0 and 300 kilolitres of usage, the charge is just 200. Then it's going to start to go up for every extra kilolitre you use. It's going to then have a charge of 200 plus $1.50 for every kilolitre we use. And that's going to go all the way up until the end of this bracket. When you're using 600 kilolitres of water, you'll be charged the top amount for this bracket, which I'm saying should be $650. Now you can check that out for yourself. You'll be charged $200 plus $1.50 times the number of excess kilolitres you use above 300, which is 300 extra. So 300 times $1.50 plus the 200 should work out to be the start of the next bracket. They would charge you $650 if you use 600 litres of water, because that's the end of that bracket. It's got to be the same. They're going to charge you the same if, according to this bracket, you use 600 kilolitres of water. For 600 kilolitres of water, the charge is $650. So I can put that point on the graph. And that 650 would be about there. And this graph is going to slope up evenly between these 2 points. Sometimes it's a good idea to mark and actually write what the points are on your graph. This is the point 300 kilolitres cost $200. This is the point 600 kilolitres cost $650. And then the graph goes up, and it goes right up, and we worked out for 1,000 kilolitres the cost is $18.50. Let's see where that is on the graph. That's $18.50. It'll be just above there, somewhere about there. And there's our graph. Now, part C of the question, if I can move this up again. Part C of the question asks us to use our graph to confirm part A. In part A, we worked out the charge for using 520 kilolitres of water. Well, let's use the graph. Go up here to 520, it'll be about there. Go up to the graph, go straight up, and then straight along. What do we get to? Well, it looks like it's somewhere between 500 and 600. I'd say approximately $550, but it's hard to tell off the graph. When we did it using the table, we got 530. I reckon that'll be a bit more accurate than that, but it's showing that the maths is working okay. Part D of the question says find an equation to represent each of the line segments of the graph. And part E of the question says use one of the equations to confirm the answer from part A. Now I'm not going to do all three sections of the graph. I'm just going to do this middle section because otherwise the video is just getting a little bit too long and a little bit boring. So let's just find the equation of that middle section because we'll be able to use that in part E. Okay, to find the equation of part of a line, you can use the coordinates here. We can work out the gradient between those two. The gradient is equal to, remember, y2 minus y1 over x2 minus x1. The difference in the y's over the difference in the x's. This can be our y2s, x1, sorry, x2, y2, x1, y1. It's going to be 650 minus 200 over 600 minus 300. That will work out to be 450 over 300, which works out to be 1.5. Do you see where 1.5 comes from? Relative to this section of the graph, this is the section here. The 1.5 is the rate at which we're being charged for water usage. That's the gradient of that section. Now we can work out its equation using the formula y minus y1 equals ax minus x1. Okay, y minus y1, I'm going to, y1 is 200, isn't it? So it's, I have to move this up a little bit. So y minus 200 equals 1.5, x minus x1 is 300. Y minus 200 equals, multiply out the brackets here, 1.5 x minus 1.5 times 300. $450. And that means that y is equal to 1.5x and add 200 to both sides minus 250. This equation tells you the charge on the y-axis for water usage on the x-axis. So I could make it and say charge equals 1.5, and I could say times W for water usage minus 250. Let's see how this equation works if we want to check the answer to part A. Now it's very important that when we're doing this, this equation we've worked out is the equation of this section of the graph. Now only the equation for this section of the graph would do, because the prediction we're asked to make intersects with this part of the graph. So you would only use this section of the graph and none of the other sections of the graph, none of their equations would work for it. Okay, so if we want to, part A asked us to work out the charge for 520 kilolitres of water. So the charge will equal 1.5 times 520 kilolitres of water minus 250. Now we can do that on the calculator easy enough. 1.5 times by 520 equals minus 250, and charge works out to be $530, exactly what we got in part A and similar to what we got when we did it by graphical means.